All right, hi guys. So today what we're going to be going over is we're going to be starting our very last unit. I know it's kind of crazy that we're on the very last one. The end is near. So what we're going to be looking at is we're getting into our unit on slope inference. And so to start, what we're going to be doing is we're going to be performing a confidence interval, specifically a t interval, which is the same one we did to, excuse me, we used to predict means and difference of means. Today we're going to be using that to predict the slope of a population regression line. Okay, so with that, make sure you have your notes titled and let's get ready to go. Now, so first I want you all to understand a couple of things about the regression lines. It has been a hot minute since we talked about linear regression. That was all the way back in like October, November-ish, okay? But first, with these types of intervals, okay, in this unit, we have two different regression lines we're going to be looking at. We have the population regression line, and here in a second, we're going to look at the sample regression line, okay? So just like other intervals and other hypothesis tests, we're going to do a test here in this unit as well, okay? We have the population characteristics and we have the sample characteristics. And we're going to be using the sample characteristics to test for the population characteristics, okay? So for my population regression line, I have mu of y equals alpha plus beta of x. Okay, again, that is mu of y equals alpha plus beta x. Okay, make sure you don't write those down as a's and b's. Those are alphas and betas, okay? Now, mu of y represents the mean y value for my population, okay? This is the average of the entire population, all of the y values for the population, that's the average, okay? And because it's the mean y value, that's why we're doing a t-interval here, okay? Alpha represents the y-intercept of my population, and it makes sense that beta is the slope of my population. So again, this is the, regression line of the whole population, but this is not what we are given, okay? What we're usually given in some form or another, we'll look at that here in a minute, we are given the sample regression line. So that is from the random sample that we take and we're using our math, doing the analysis of. The sample regression line is y hat equals a plus b x. Again, this is y hat equals a plus b x. And so this is a and b versus for the population it was alpha and beta. So make sure you write those carefully, okay? Now, y hat is my predicted y value, again, based off of my sample. All right? And again, following along with the same theme, a is my sample y-intercept, again, based off of our random sample, and b is the slope of our sample, okay? And so these characteristics we are going to use to estimate our population regression, okay? We are specifically going to be predicting beta. We're specifically going to be predicting the slope, which is why the title of these notes was the t-interval for slopes, okay? That's the specific value we're going to focus on, okay? Now, first thing to make note of is there's a lot more conditions than usual, okay? Usually, we check, is it random? Is it independent? Is it normal, okay? Because we're dealing with regression lines, we got a lot of moving parts here. It's quite literally a linear graph going all the way back to like when y'all did Algebra 2 and whatnot a few years back, okay? But thankfully, what makes our life a hair easier is the names of all the conditions, we can create an acronym. The acronym is LINER, okay? So if you are getting mixed up on all the conditions here, just remember LINER, okay? And so with that, our first condition is linear. We want to ensure that the scatter plot of our sample is linear, or if they don't give us the scatter plot, a lot of times they'll give us the residual plot instead. We want to ensure the residual plot has no pattern, because again, thinking all the way back to our unit 2 notes, it's been a minute. If the residual plot has no pattern, that indicates that my scatter plot is linear. So we want one of those two, either or meets this condition. The I stands for independent, so that's my 10% condition. Okay, same as normal. Sample size, less than 10% of my population. That's Old Faithful there, okay? The N stands for normal. Now, we've checked for normal before, But again, with a regression line, it's a little bit different, okay? So what we have to what we have to check is either the residual dot plot or the residual histogram. And again, those should be provided to you on a question like this, okay? But whichever one, the dot plot or the histogram, we want to ensure that it shows no strong skewness or outliers, which that is something we've checked for before, but used to it was just an option. Now it's completely required that we have to check it this way, okay? The E, this one's kind of weird. It stands for equal standard deviation, or usually it's abbreviated equal SD, okay? And what that basically means is we just want to ensure that the residual plot has no cone pattern of sorts, which implies that the standard deviation is equal for all of my data. That one's kind of weird, okay? So again, basically, the simple version of the answer is make sure it has no cone pattern. And so for this, we use the notation, the residual plot shows no, and we use the less than and greater than symbols to show the two different directions of a cone that it could show. And so again, this, all right, if y'all can see my mouse here, residual plot shows no less than or greater than pattern. That's showing the two cones. Okay, we're going to write that exactly every time. And then the R stands for random. Again, just is it a random sample? Again, good old faithful, okay? So while some of these aspects are the same, we just have a lot of additional parts here because we're dealing with a regression line, okay? So again, make sure you take these notes thoughtfully, okay? And especially on the equal standard deviation one, make sure you write that down correctly. Now moving on to my calculations. My calculations can go one of two ways, all right? We have two different options for doing the math, and it's purely how the data is presented to us, because the first option is they could give us a table of data. So like they could give us our sample data as a list of X values and Y values. Okay. They don't actually give us the graph. They just say, hey, here's the data. Go do things with it. Now they will still give you the residual plot. They pretty much have to give that to you just because it's so time consuming for you to do it on your own. But if they give you a table of data, okay, in our calculators, when it comes to the calculation steps, you're going to type your X values into L1 and the Y values into L2. Just copy it from the table into your calculator, okay? And then once all of that data is inputted, we get to go over to the stat tests option in our calculators, and we go to option G. It's not the last option, it's the second to last option, okay? And when we get to an example of this, we'll do this together, okay? But it's option G, which says lin, reg, t, interval. All right, this stands for linear regression t interval. It's very specific for the t interval of a slope. Okay. All right, and so it should automatically have your X and Y values as L1 and L2. You shouldn't have to change that. You just have to make sure you type in the correct confidence level. So if you're doing a 95% confidence interval, make sure you say 0.95 in there, okay? And then you let the calculator do its magic, and you simply write down the interval it gives you, the degrees of freedom, and the B value. That's your sample slope, okay? And so those are the three things, because it's going to give you a lot of numbers, okay? But doing a confidence interval, those are the three. You do have to do your t-score manually. That's our t-star value, and we're going to review how to find that here in just a second. But that one you do have to do on your own. The test won't do it on your own. All right, now, the more ideal option, and this is what we're going to do in this video together, is if you're given the sample regression values, if you're given the computer output, usually is what it looks like. It's been a minute since we've looked at those, but we have seen those from time to time. This is the more ideal way they're going to give it to you, at least from what I've looked in College Board. This is the more likely way that you are going to see it. Okay, not that the table of data isn't an option. I've just seen a lot more questions in AP Classroom with the computer output instead of a table. And so if you're given the sample regression, you're given all of the data up front, okay? First, you have to calculate your degrees of freedom by hand by using n-2. We've been doing n-1 this whole time. You have to do n-2. It's linear regression. It's already weird. Might as well make it a little bit more. But you have to use n-2 to find your degrees of freedom. Please make sure that when you write that down, you highlight it, you bold it, you underline it, whatever. Please make sure you don't confuse this. To calculate your t-star, okay, that's your critical value. Remember, you input it into inverse t, okay, and we will do that on the example here in a minute. Inverse t, Degrees of freedom in minus 2. For your area, you do 1 minus your confidence level divided by 2, okay? We have done that before. It has just been a minute, okay? But you have to calculate that by hand. Once you have your T star and you write it down, you're going to use B plus or minus your critical value times your standard error. Remember, those two together make your margin of error, okay? Now, remember, B is your sample slope. If you're given the regression computer output, that should be given to you. And the standard error should also be given to you. Okay, again, this should be given to you. But on the off chance it's not, they do give you all the equation on your formula chart. It's just kind of messy. Okay, but I have noticed for the most part that if you're given the computer output of your data, usually that math is done for you. But just to be safe, go ahead and write this down. But I will say I do kind of doubt that we're going to use this, okay? So at this point, we're going to switch over and do an example. And so we're going to end this, and we're going to switch over. Now, we are going to be doing this scenario right here. This scenario is listed separately on Canvas, okay? And so how you choose to write this into your notes is up to you, okay? I would definitely make sure you write down the question, do the computer output. As for your 3 graphs, if you want to draw a rough sketch of them in your spiral, that would be fine. You don't need a detailed one, okay? I'm going to recommend you pause the video at this moment and draw these graphs before you go forward. All right, guys, welcome back from writing down all of the information for the scenario. So just to run through what we're doing real quick, we are seeing, based on if we know the number of miles on the odometer, can we predict the price of a used Ford F-150 Super Crew 4x4? Okay. And so it tells us that a random sample of 16 used Ford F-150 Super Crew 4x4s were selected from those listed on autotrader.com. And then number of miles driven and the price were recorded for each of those trucks. It says to construct and interpret a 90% confidence interval for the slope of the population regression line. And so what it's given us is, it has given us the, starting in the top right here, they've given us the residuals in a histogram, okay, which is important, we need that. This is just our typical regular residual plot. This here in the bottom left, this is our scatter plot with a line of best fit. We don't necessarily need all of these, but just wanted to show y'all everything that a question could give you. And then lastly, it's given us the computer output here, okay? And so just real quick, all right, if y'all see where I'm pointing with my mouse right here, circling, this negative 0.16292 next to miles driven, that is my slope. That is my sample slope. That is also known as my B value, okay? If you want to make a note of that, that is my B value here. And then this right here that I'm circling, the SE coefficient next to miles driven, that is actually the standard error of my slope, okay? Also known as my S sub B value, okay? Again, S sub B value. And I'm actually going to go ahead and mark that here. Okay, let's go with purple. I hope y'all are okay with that. And so now what I'm going to do, pen come alive for me, is, oh, how about we not do that? That's rude. All right, so again, that right there is B. And then this guy here, that is S sub B. All right, and really out of this whole computer output, those are really the two that we need to know for the sake of doing this confidence interval, okay? The other values we might use at different times, but for a confidence interval specifically, we don't need that today, okay? And so now I'm just going to go into our favorite acronym, panic. All right, we are still going to panic because this is still a confidence interval. So we're going to start with my parameter. Now, in my parameter statement, I always just want to define what is beta, okay? Remember a second ago, we said that beta is the slope of the population It's the slope of the population regression line, but in order to define it for this problem, to define my parameter truly, is we're going to add our context. So it's the slope of the population regression line relating, that's a G and an N, I can't write, y'all, sorry, y equals, and in this problem, it says if we know the miles, can we predict the price? And so that means y represents my price. So we're relating y equals price to x equals the miles driven. And now we have to specify what this is for. And this is, for this problem specifically, this part is a little bit long. They're not always this long. But we're doing this for used Ford F-150 Super Crew four by fours for sale on autotrader.com. Okay, I do have to specify like every aspect of the Ford F-150s, and I also have to specify for sale on AutoTrader because that is where this sample came from. So that is the population that I can relate it back to. Okay, so that's my parameter statement. Okay, just you're defining what beta represents because beta is what we are predicting. Okay, so now I can go on to A. Now remember, those are my assumptions, and this is where we're going to use liner. Okay, remember that's linear, and we'll go ahead and fill it. We'll do them one at a time just for spacing. So linear. Okay, so for linear, remember I either need a linear correlation on my scatter plot or I need absolutely no pattern in my residual. Here I have both, so I don't need to speak to both. And so more often than not, you're probably going to see the residual plot. So for practice, we're going to say there is no pattern on residual plot. Because again, more often than not, that's what you're going to refer to. Now remember, I stands for independent. And that's my 10% condition. So it told us that it was a sample size of 16. So we're going to say 16 is less than 10% of, and again, our population is weirdly specific on this one, of used Ford F-150s, or Ford 150 Super Crews. Super Crew 4x4s for sale on AutoTrader. Again, weirdly specific. And that chicken scratch at the end, I don't know what happened there. Okay. So again, L-I, remember N stands for normal. And for normal, remember that's where we check the histogram. Okay. Histogram or dot plot, depending on which one they give you. Today they gave us the histogram. So we're going to say, we have to specify that it's the residual histogram. We can't just say histogram. Residual histogram. All right. And as far as I can tell, there's no strong skewness or outliers here. This guy is a little tall in the middle, but I wouldn't call that, we're not going to call that an outlier. Remember, outliers are on the edge of our data. So our residual histogram shows no strong skewness or outliers. I think it looks pretty good. Now remember, equal. Remember I said we could abbreviate it SD, equal SD. Now, looking at my residual plot, again, if it had a cone pattern, it would be pretty obvious that it either went like this, or if I erase this, your data would look like that again. It would be a pretty obvious cone pattern, and this has neither. And so we're going to say there is no this or this. Okay, my little signs here. Right, neither pattern, because that implies a cone. So that pattern in residual plot. Okay, again, this is all over the place. And then Random? Yeah, it says right there that it was random. So yeah, the assumptions is by far the longest section here, which is a little bit annoying, but we'll live. Now the name of our interval, we are doing a t-interval for slope at 90%. What happened to the C? That's fun. At 90% confidence. I'm going to have to scroll down just a hair here. Now let's get to my interval calculation. So again, I was given the computer output for this one. So we are not going to use the test in the calculator. I will try to get us to practice that at some point. But for today, we're gonna have to go by hand. Okay. So first, I'm gonna start with my degrees of freedom, which remember that is n minus 2. So my sample size was 16 minus 2 gets us a degrees of freedom of 14. Okay. Now, my t star. Okay. We're gonna say for my area, that's 1 minus 0.9 over 2, which is 0.05. So over in my calculator here, okay, I'm actually going to switch him over. Please stop doing that. That is rude. Please stop doing that. This thing doesn't like me today. And you know what? That's fine. We'll be okay. He'll just dislike me and it's okay. All right. So where was I? All right, so we're gonna go to second vars, and we're gonna go back to our good old friend inverse t, and we're gonna put 0.05 in for my area. Didn't mean to do that second 5, oopsies. And we're gonna put in that degrees of freedom of 14. We're gonna go paste, and we're gonna record our t star value as 1.761, if y'all are okay with that. Actually, we'll just do this. All right, and we're gonna say t star equals 1.761. Okay, now for my interval, okay, remember we're gonna do b plus or minus t star times my standard error. And so going to my computer output, all right, remember it told us our b value was negative 0.16292. I know it's a long number, but to be precise and accurate, we are going to use the full thing. And then I'm going to say 1.761 times, and it told us that standard error was 0.03096. Okay. Again, just as a reminder, b value right here, s sub b is right there. So now I'm going to go plug this into my calculator over here. So I'm going to say negative 16292. We'll go ahead and say minus first, and then we're going to do 1.761 times 0.03096. And we're going to see what that number gets us. That's going to get us our lower number. So my interval is going to be negative 0.21. We'll say 217. We'll estimate a little shorter. And then remember, I'm going to go up here. And I'm going to say plus to get the higher end of my interval. And that is going to be negative 0.108. Okay, so that's my interval right there. And so with that, I can use that for my conclusion. Remember, it always starts out with today we are 90% confident that the interval negative 0.217 to negative 0.108 captures the slope remember we predicted a slope today, captures the slope of the population regression line relating, and we're going to repeat our entire parameter statement basically. Y equals price to X equals miles driven for used Ford F-150. Oh, sorry, guys, this is getting tight. I didn't leave myself enough space. 'Tis my bad. Super Crew 4x4s that are for sale on autotrader.com, and boom, we're done. All right. So, please make sure you wrote your notes thoroughly. You are welcome to go ahead and start on the front page of your assignment. Only the front. Don't worry about the back just yet. And if y'all have questions, you're welcome to ask me tomorrow when I get back, or shoot me a remind message. Have the most fantastic of days, guys.